Hello, fifth graders, and welcome to a read aloud of today's science ebook, that being this one here called The Scoop About Measuring Matter, as needed for today's science lesson, Unit 2, Lesson 4, Identifying Matter. So today's assigned reading pages are pages 4 through 21, so let's go ahead and get to page 4 right now and start there. So here we are. Page 4, The Matter of It All. Everything in the universe is made up of matter, from things smaller than grains of sand to things larger than gigantic stars. Matter is anything that has mass, meaning it is made of an amount of something and it takes up space. Now, matter includes things that you can't see, such as air, but you can see that air takes up space if you blow up a balloon. Matter of fact. Scientists may study the mass of matter in their work. For example, the mass of butterfly bodies could reveal clues about how they survive migration. By studying the survivors and those that died along the way, researchers might learn if body mass or food influenced those that live. States that matter. Tiny moving particles called molecules, which themselves are made of atoms, give matter its physical properties. Matter of fact. Everything around us, both natural and man-made, is made up of atoms. An atom is the smallest particle of any substance. Millions of atoms exist in just one of your eyelashes. When two or more atoms bond, they form a molecule. For example, this is a water molecule. You can see it is an oxygen atom bonded with two hydrogen atoms to create what's called a water molecule. Scientists know of 5 main physical properties, called states. Only 3 are common: solid, liquid, and gas. Supercold Bose-Einstein condensates and plasmas are the 2 most recently discovered states of matter, although those are very, very rare. Speaking of solids, liquids, and gases, we have examples right there. There is water in a solid state, ice, water in a liquid state, which of course is just regular liquid water, but also water in a gaseous state, that being water vapor or steam. So adding or removing pressure, motion, or heat changes matter from one state to another, but matter is matter in any state. Water is water if you add heat to make steam, gas, or remove heat to make ice, solid. So whether it's solid, liquid, or gas, all 3 of these are still water, made up of water molecules like this one. Plasmas help create the vibrant colors of the aurora borealis, or northern lights, and images in plasma TVs. Molecules in every state move all the time. Some move more slowly than others, such as molecules in a solid. These molecules are tightly packed together, which gives the solid its definite shape. A solid doesn't need a container to hold its shape. So stones are solids with very tightly packed molecules. So we got some stones right there. If we were to take a super-powered microscope and zoom in on the molecules that make up those stones, you'll see that they'll look something like this. They're arranged in a very tightly packed, rigid pattern and can't easily be moved. So these are solids. A liquid, then, does not have a shape, or at least it doesn't have a shape of its own. It takes the shape of its container. Molecules in a liquid loosely flow under and over each other. So we've got ourselves a glass of juice. If you were to zoom in again with a superpowered microscope to look at the molecules that make up that juice, you'd see that they kind of flow around each other in a liquid state. So liquid molecules slip around each other. This allows a liquid to flow from one shape to another. For the third state of matter, a gas, like a liquid, does not have a shape, or at least it doesn't have a shape of its own, but it completely fills the shape of its container, like so. Fast-moving molecules in a gas have a lot of space between them and bounce off the container's walls. So those gas particles inside there bouncing around inside that flask, with no shape or volume of their own, but able to move about freely, with a lot of space in between them. Measuring units. Scientists measure matter using what's called the International System of Units, which is based on the metric system. For example, the gram shows mass, or the amount of matter in an object. The liter shows volume, or the amount of space the matter takes up. So we have a scale right there that's being used to measure the mass of, looks like maybe some Cocoa Puffs. And we got some graduated cylinders and flasks which are used to measure the volume of some liquids there. Common tools for measuring matter include a graduated cylinder, that's this thing right there, a flask, that thing right there, a balance scale for measuring mass, a ruler for measuring how long something is, a syringe, or a dropper. Every tool must be carefully cleaned after each experiment. Matter left in a tool may change the results or create stinky or harmful mixtures. Scientists usually store tools in dust-free cabinets to keep them clean. Measuring mass. So how do we measure how much matter is in an object? Mass and weight are different measurements. It's good to know. Those two things can be confused a lot of the time. Your mass might be 30 kilograms or 66 pounds on Earth. Because space has no gravity, you would weigh 0 kilograms or 0 pounds there, but your mass would still be 30 kilograms. So your weight may change depending on how much gravity there is, but your mass will still always be the same no matter where you are. So a body's mass on Earth stays the same in space. That's because mass is the amount of matter in an object, or how many atoms or molecules make up an object, while weight is a measurement of gravity's pull on an object. Some other ways to measure mass: a spring scale measures weight, or how much the spring moves down because of gravity's pull on the load. So that's a fish being weighed by a spring scale there. A balance scale, another type of scale, finds the mass of matter. A known mass is added to the pan on one side until that arm balances with the matter on the other arm. A triple beam balance also measures mass, mostly in laboratories. So a triple one could be used to measure the mass of 3 things all at once. So the balance scale is the oldest known tool for finding mass or weight. They've been around a long time. Mass stays the same when an object changes physical properties, such as state, color, or shape. Mass also stays the same in a chemical reaction when two combined materials change into an entirely new material. So we got ourselves a big ball of clay. If you were to reshape that ball of clay into a frog figure like this, it's still the same amount of clay and therefore would have the same amount of mass. In other words, if you can count every single atom or molecule inside this ball of clay, that model frog that you made would have the same number of atoms or molecules inside of it, same exact mass. So the shape of the clay has changed, but the mass of the clay frog stays the same if you made it just using all of the green clay. After physical or chemical changes, the new mass may seem smaller if some original matter has turned into gas. Burning logs turn into ash and smoke, which is a gas. Add the mass of the gas to the remaining matter. It equals the mass of the original matter. We also got what's called the law of conservation of mass, which was coined by Antoine Lavoisier, French scientist. In 1789, French chemist Antoine Lavoisier proved that mass put into a reaction equaled the mass that came out of the reaction. No new mass, and no mass destroyed. Voila, you have the law of conservation of mass. So no matter what reaction may happen, you're always going to have the same amount of mass in your substances before the reaction as after. No exceptions. Measuring volume. Okay, so we just got done measuring mass. Now let's see how we measure volume, or how much space an amount of matter takes up. Matter takes up space, but how much? We measure its volume. When matter is a liquid, measure its volume with a measuring cup, like this one, or with a graduated cylinder, like we saw before. So this would be measuring the liquid volume, which is the space filled in a graduated container in milliliters. That's the unit we use to measure volume of liquids. When matter is a solid, on the other hand, measure its volume with a ruler and multiplication. So if you have a big granite cube like this one, you can actually measure its volume, or how much space it takes up, by taking a ruler and measuring its length, how long it is, its width, how wide it is, and its height, how tall it is, and then multiplying all 3 of those amounts together. So solid volume can be found by calculating an object's length times its width times its height, using centimeters in this case. That's something we'll actually practice in our math class later this year. Measuring the mass of gas can be tricky. Some gases can be measured by sucking them into what's called a syringe. That's this thing right here, a gas syringe. Scientists often use an electronic tool that controls the amount of gas flowing and that measures its volume. So the force of air rushing out of a person's lungs makes the red indicator move in this peak flow meter. That's that thing right there. It measures the amount of air moving out of the lungs. This measure shows if breathing is normal or if the airways are narrowing. So essentially what this is used to measure is how hard a person is breathing. Matter of fact, people with asthma may use a peak flow meter, one of these things, to measure the rate or speed of gas flowing out from their lungs when they forcefully exhale. This allows doctors to track how well patients are breathing. So indeed, gas may be tricky to measure in terms of its mass, but it is possible. So gauges attached to scuba tanks measure the air inside. The gauges measure the volume of gas leaving the tank and show the volume of gas that is left in the tank. Measuring matter helps scientists identify materials and understand more about the world. Careful measurements could mean better medicines, new products, or even a better cake at home. And just a quick review of some of the vocab terms we learned in the reading today. Balance scale, that's that scale that they use to measure or compare the mass of two different objects. Graduated cylinder, used to measure the volume of a liquid. Gravity, the force that pulls all objects towards Earth's center. Mass, the measure of how much matter is in an object. Physical properties, those being qualities or traits that something has. Spring scale, another tool used to measure mass, like the one that was used to measure the fish earlier. States, those being the possible forms that matter can take, the three most common being solid, liquid, or gas. And volume, that being the measurement of how much space a certain amount of matter takes up, whether it's a liquid or a solid. So that will do for today's ebook reading, everybody. Thank you so much for joining me today. Continue with your science lesson, and I look forward to seeing you in our next class together. Take care. Have a good day.